Rates 2019. Tricky one this, because you've got to know that a rate is a change in concentration divided by time. You should know that anyway, but it's how much the concentration has changed divided by time. You know concentration is moles divided by decimeter cubed. And divide by time puts an S on the bottom as well. That's the units of rate. Mole per decimeter cubed, concentration, how much that has changed divided by time over time. So let's have a look at experiment 1. The concentration changed from 1 times 10 to the minus 2 to 0.92 times 10 to the minus 2. So if you subtract that, it ends up as 0.08 times 10 to the minus 2. That's the change in concentration divided by how much time it took. So that was over 5 seconds, so you divide by 5. So it's 1 times 10 to the minus 2, take away 0.92 times 10 to the minus 2 is 0.08 times 10 to the minus 2 divided by 5 seconds. And you do it for the others as well. 2 times 10 to the minus 2 take away 1.84 times 10 to the minus 2 divided by 5. And the last one, 0.5 times 10 to the minus 2 take away 0.34 times 10 to the minus 2 divided by 5. So you get all the changes in concentration and you divide by how long it took. And you get the initial rates then as 1.6 times 10 to the minus 4, 3.2 times 10 to the minus 4, and another 3.2 times 10 to the minus 4. Tricky question. Once you've got that, then determine the order with respect to P and the order of reaction. So I'm going to which experiment's going to choose. What has Q not changed? Q hasn't changed. The concentration of Q times 0 hasn't changed in experiment 1 and 2. It's still 1.25 times 10 to the minus 2. So I'm going to use experiments 1 and 2. And I'm going to look at the concentrations of P, 1 times 10 to the minus 2, 2 times 10 to the minus 2, and I've got the rates. So I've got P, 1 times 10 to the minus 2 in experiment 1, and 2 times 10 to the minus 2 in experiment 2. I've got the rate, I've got the concentration of Q, which hasn't changed, let's say at 1.25 times 10 to the minus 2, and I've got the rates 1.6 times 10 to the minus 4, 3.2 times 10 to the minus 4 for my calculation. So now I can do my usual thing, 1 times 10 to the minus 2 divided by 2 times 10 to the minus 2 to the power of whatever the order with respect to P is. I've called it X. 1.25 times 10 to the minus 2 divided by 1.25 times 10 to the minus 2 to the power Y. That's the order with respect to Q. That's not going to matter because it's going to cancel anyway. 2 rates, 1.6 times 10 to the minus 4 divided by 3.2 times 10 to the minus 4. I could flip it if I wanted to. I've kept it the same, to be honest. 0.5 to the x equals 0.5 because that middle one is going to cancel. 1.25 times 10 to the minus 2 divided by 1.25 times 10 to the minus 2 is going to cancel. So x must be 1. So order with respect to P is 1. And then it's asked me to do the same for Q. So I take the two experiments 2 and 3 this time. Concentration of P, 2 times 10 to the minus 2, 0.5 times 10 to the minus 2 over experiments 2 and 3. Concentration of Q in experiment 2 was 1.25 times 10 to the minus 2, changes to 2.5 times 10 to the minus 2 for experiment 3, so this should be experiment 1 and 3 actually there. 2 and 3 even. Between 2 and 3. Yep. Between experiments 2 and 3 I've got concentrations of P, concentrations of Q, and I've got the rates. The rates don't change between experiments 2 and 3. The rate is 3.2 times 10 to the minus 4. Both of those. So let's plug it in. Concentration of P, experiment 2 divided by concentration of P, experiment 3 to the power 1. How do I know it's to the power 1? Because I've just calculated x was a 1, the order with respect to P was a 1. Q, 1.25 times 10 to the minus 2 divided by 2.5 times 10 to the minus 2 to the power of unknown. That's what we're trying to find out. We'll call that y, and the two rates are the same. 2 times 10 to the minus 2 divided by 0.4, and 5 times 10 to the minus 2 is 4 to the power 1, is just 4, multiplied by 0.5, 1.25 times 10 to the minus 2 divided by 2.5 times 10 to the minus 2 is 0.5 equals 3.2 times 10 to the minus 4 divided by 3.2 times 10 to the minus 4 is 1. So divide both sides by 4, 0.5y equals 0.25. Tricky one this. What number is it? Is it a 0? No, because 0.5 to the power 0 would be 1. It's not 1, it's 0.25. 0.5 to the power 1 would be 0.5. It isn't a 1. 0.5 squared, half, 0.5 times a half is a quarter, and a quarter is 0.25. It's a 2. And then the last bit, 4.3, is just plugging numbers in. It says, you've got to write a rate equation, and it's giving you the rate equation in words. It says, at a given temperature, the initial rate was 1.2 times 10 to the minus 2. So the rate is 1.2 times 10 to the minus 3, is rate constant K multiplied by R. It's R and S, that's okay. It says second order with respect to R, so I've got R concentration squared. Second order with respect to S, so I've got S squared. I've got the concentration R, 1 times 10 to the minus 2, that's squared, because it's R squared, because R is second order. 2.45 times 10 to the minus 2 is S. That's S squared as well, because it says order with respect to S is second order. Put the numbers in, rearrange. K is 2 times 10 to the minus 4. I've put it to 2.00 to 3 significant figures, because the data in the question is 3 significant figures. What am I going to do for units? Ooh, tricky one. Rate is mole divided by decimeter cubed divided by second, so mole divided by dm3s. Fine. K, don't know, I'm trying to find the units of that. And then I've got mole per decimeter cubed times mole per decimeter cubed times mole per decimeter cubed times mole per decimeter cubed. 4 of them, because I've got concentration squared for R and concentration squared for S. So, divide both sides by a mole. Okay, cancel a divide by mole per decimeter cubed, and I end up with S on the bottom still, and 3 moles on the top on the right, and 3 dm3s on the bottom on the right. Take the dm3s from the bottom on the right and drop them onto the top on the left. 3 moles on the right on the top, drop them onto the bottom on the left. I've got the units of K are dm3, 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 which is dm to the 9, divided by mole, 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 which is mole to the power 3 and an S. The mole to the power 3 and the S to the power 1 on the bottom become mole to the minus 3 and S to the minus 1 on the top, in any order you wish.